Chapter 9, Inheritance and Interfaces, Part 4. So polymorphism. In question demo 2 that's in your textbook, we're past two choice question objects to the present question method. Can we write a present question method that displays both question and choice question data types? And how would that work? So the answer is yes, we can. And let's look at the method header. Public static void present question, question Q. Remember that you can a subclass object can be used where a superclass reference is expected. So a subclass reference can be used where a superclass reference is expected. So if we're calling a method and question Q is the parameter, we can supply a reference to a choice question and it's fine. So the variable of type choice question, let's assume that it's second and it references a choice question object, and then the variable of type question Q will reference the same object when we call the present question method, and that's fine. That's polymorphism in action. So present question simply calls the display method of whatever type is passed. So if we're passing an object contained in a reference, either a choice question or a question reference, to the present question method, when it encounters q.display, whatever the object type is, it calls that display method. And this is known as dynamic binding. Or late binding. So at runtime, it's going to say, okay, what's the object type? That's the method I'm going to call. If it's past an object of the question class, question display is called. If it's past an object of the choice question class, choice question display is called. So the variable Q does not know what type of object to which it refers. It knows it's got to be a question type, but it can be choice question because choice question is a question. It doesn't know which type it refers to, but it's fine because it's got the display method inside question, it's got the display method inside choice question, and so at runtime it'll figure that out and call the right one. In Java, method calls are always determined by the type of the actual object and not the type of the variable containing the object reference. So this is called dynamic method lookup, also called dynamic binding. It's the same thing, and happens at runtime. So at compile time, the method has to be there for the superclass. It's got to be there for that superclass reference to find at compile time. But then at runtime, it will use the actual object type to be able to run the right method. This is called polymorphism. And it lets us write code that's responsive and lets us write code that's flexible. And we ask multiple objects to carry out a task, and each object does so in its own way, which is pretty handy. Polymorphism makes programs easily extensible. We can extend the features of the programming language. In fact, that's an object-oriented programming paradigm, to be able to extend the programming language. And in fact, we've kind of been doing that for months, because writing your own classes is really creating your own data types, isn't it? And if you're creating your own data types, you're extending the features of the language. You're implementing extensibility, which is kind of cool. Let's take a look at some self-checks. Assuming that savings account is a subclass of bank account, which of the following code fragments are valid in Java? If we have a bank account reference called account, can it reference an object of type savings account? Yes, because reading from right to left, savings account is a bank account. That passes, that is a test. So A is true. Let's look at number B. Savings account, account 2, equals new bank account. So again, reading from right to left, bank account is a savings account. That's not true. There are different types of bank accounts. There's also checking accounts. So B will not work. It's false. And C, bank account equals null. Null is the explicit way of saying nothing in Java. And so what we're basically doing is we're creating the bank account reference, but we're not creating a new object yet. We're just saying null. So that'll work too. That's fine. If account is a variable of type bank account that holds a non-null reference, what do you know about the object to which account refers? Well, we know that the object to which account refers has access to all of the public interface inside a bank account. So it's got access to the deposit, the withdrawal, the get balance. Do we know anything else about it? Not really, unless we know what type of object it is. So it belongs to the bank account class or one of its subclasses. Declare an array quiz that can hold a mixture of question and choice question objects. So think about how we would do that. How would we declare an array called quiz that can hold a mixture of question and choice question objects? Recall that choice question is a question. So think about, imagine what that UML diagram looks like in your mind. And so what needs to come first? Question needs to come first. Question, and then square brackets to indicate it's an array. We'll call it quiz. New question, size, whatever size is. It didn't tell us in the problem how big to make the array. Recall that arrays are not resizable, so you cannot change the size of the array at runtime. If you wanted to be able to do that, you would have to use an array list. So is the method call math.square-root2 resolved through dynamic method lookup or dynamic binding? No, because square root is a static method of the math class, and therefore it's subject to early binding. Static methods are subject to early binding or static binding because they are resolved at compile time, not at runtime. So there's no implicit parameter object that could be used to dynamically look up a method. So static methods are bound to the method calls are bound to the methods at compile time, and with instance methods, they're bound at runtime. Add the implicit parameter to, if we want to use dynamic method lookup, we can add the implicit parameter to the code to find out what is going on. Because of dynamic method lookup or dynamic binding, the choice question versions of display and check answer methods are called automatically. So based on the object type, it calls the right one. You can use this to make it even more clear, this dot display and this dot check answer in the code shown in the gray box. And sometimes this helps make your code more readable. This happens through the present question method, is declared in the question class, and has no knowledge of the choice question class. So that's pretty cool. Even though we're looking in public class question, public class question has no knowledge of present question. However, if you have, has no knowledge of choice question. If you are calling, let me restate this. If you have an object of type choice question and it's calling the present question method, there's not a present question method inside choice question. I said that wrong. Yeah, there's not. And it's calling this dot display from present question, whose display is being called. It's calling the, I misspoke a second ago. I told you don't need this. You do need this, because if you leave this off, it's going to call the method in the question class and not the method that refers to the object. So you do have to provide the implicit parameter this in order to get it to call the right method. Otherwise, it will call the method in the current scope. So, special topic abstract classes, and this, of course, it's a special topic, but it's required for the AP test, so we need to know about abstract classes. It is desirable sometimes to force subclasses to override a method of the base class. And if we want to do that, we can declare the method as abstract. So if we're looking at a class called account, we could say, inside that class, we could say public abstract void deduct fees, if we want to have an abstract method that needs to be implemented in subclasses. Note, when a class contains an abstract method, such as public abstract void deduct fees, then the class must also be abstract. So if you have an abstract method inside a class, that class must also be abstract. It is possible to have an abstract class without abstract methods, but you cannot have an abstract method if it's not inside an abstract class or an interface, but we'll get to those shortly. You cannot instantiate an object that has abstract methods, so the class is abstract. You can instantiate objects of concrete classes, classes that are not abstract. We don't have a keyword concrete, but they are classes that are not abstract. So if you extend an abstract class, you must implement all abstract methods. So note the deduct fees method inside account. We have to write that method inside savings account because it does extend account. A class that can be instantiated is called a concrete class. A class that is not cannot be instantiated is an abstract class. You can declare an object reference whose type is to an abstract class. However, it must reference the objects of the subclass. So the actual object must be of a concrete class. Here's an example. Account, an account. An account equals new account. Can't do that because account is abstract. An account equals new savings account. We can do that because savings account is concrete. An account equals null. We can do that because null means nothing. There's no object there. This allows for polymorphism based on an abstract class, and sometimes that's very useful because we know that all subclasses are going to be enforcing the model set up by the superclass. So, final methods and classes. If you want to prevent programmers from creating subclasses, that is, you want to make sure that one of the classes you write is not used as a superclass, you can declare that class as final. For example, inside the Java library, the string class is final. You can't use the string class as a superclass for any other class. Public final class string is how that's final is used. It makes it concrete, and it makes it such that you cannot use it as a superclass. An example of a method that cannot be overwritten is using final in a method. I do not believe that final methods are part of our AP subset, but I will double check and get back to you, but I believe that they are not part of that. So public class secure account extends bank account, public final Boolean check password string password. That means we cannot override the check password method inside any subclasses of secure account.